Now in this lecture, we will discuss about the cube root of unity. So what is the cube root of unity and its properties? So when we generally x equals to 1 upon 1 into 1 upon 3. So basically it's the cube root of unity. So cube root of unity is nothing but it equals to x equals to under root, and this value is 3. So how to find it? Its value equals to 1. So how to compute the value? Now, as this equals x equals to the cube root of unity means 1 x equals to 1 and the power is 1 upon 3. So this 1 upon 3, not taking cube on both sides. So taking here the cube and here also 1 upon 3 cube. So this cube will be divided by this. So x cube equals to 3. This x cube equals to 1. And after this x cube minus 1 equals to 0. Now x cube minus 1 equals to 0. So x cube minus 1 whole cube equals to 0. So the simplification, this a cube minus b cube, this means that a minus b, that x minus 1 into a square, that is x square, then a b, that is multiply x with 1, so it must be 1, and then b square, so it must be 1, so it equals to 0. So the first value will be x minus 1 equals to 0, and the x minus 1 equals 0, so means that first root equals to x equals to 1. So for a cube root of unity, there must be three roots. This is the one root. One root means one solution of the equation. Now the second equal to x square plus x plus 1 equals to 0. So by quadratic equation, we find the two roots by using quadratic equation and one root from the common method. So how to solve it? Let's do a question. So this might be equals to this one. So there must be in the journal, you have to remove the journal roots of journal roots of cube journal roots of cube equals to 3 is equals to 3. There must be 3. So how many? So the value equal x equals to 1 first value, second value equals to minus 1 plus iota under root 3 upon 2, and the second is minus 1 minus iota under root 3 upon 2. These are basically three values. This is the first one, this is second one, this is the third one. So this is basically the three values of the equation. So this is basically real, and these two are the complex roots. These are the complex roots complex roots. So one is the real root and two are the two complex roots for a cube root of unity. Now, uh, now property of the cube roots. First property of, now there are uh, cube roots property with respect to the roots. So we know that there are basically three types of roots. So how to find it? So first I understanding again that first root is 1, second root is minus 1 plus iota under root 3 upon 2. This iota equals to under root minus 1. So this value must be equals to minus 1. Then there must be plus, and this iota means under root minus 1. So under root 3 divided by 2. So these two will multiply. So this must be minus 1 plus under root minus 3 upon 2. So this iota, this value equals to this value. So the last one is also the same. So these are basically 1, then minus 1 plus under root minus 3 upon 2, and minus 1 minus 3 upon 2. These are the three values. So prove that each of the complex cube root is the square of each one. So how to prove it? So just taking the taking the values. So first value is basically first value is this one. Now taking square of it. So square of means a square plus b square plus c square plus 2ab. So this must be equals to this one. So this means that the complex root of unity is the square of the other. So this is basically the square of the one cube root uh, is the value that is the other cube root of the equation. So the square value, that is minus 1 plus minus 3 upon 2 whole square, that the square of the any one value is equals to the other value of the root, that is minus 1 minus under root minus 3 upon. So these are the this is the general principle to know. Now there must be second is that the product of, when we are taking the product of 3, so this must be equals to the value that equals to 1. So now there is another thing. So we know that one root is, first root is 1, second root is minus 1 plus minus 3 upon 2. This is the second root, and the third root is minus 1 minus under root minus 3 upon 2. So this is basically written as 1 generally. This is written as omega, that is this is basically the value of omega, that is this one. Okay, so 1 into omega, this must be omega square. So this value equals to, that is omega cube. So after all the multiplication, when I multiply 1 with this and this, the answer equals to 1. So this means that omega cube equals to 1. So this is the second property. Hope you understand. Now the third is basically the prove that each complex cube root is reciprocal to the another. So when I am taking that this value omega cube, as we know that omega cube equals to 1 from above. So splitting omega cube, it must be omega into omega square equals to 1. So omega equals to 1 over omega square. So we know that this is the one root and this is the second root. So this is the reciprocal of the other, or omega square equals to 1 over omega. So both are reciprocal to each other. Both are reciprocal to each other. So now the last one is the sum equals to 0. That the sum equals to 0. So these are the basic properties, that when I am summing 1 plus omega square, this value equals to 0. Summing, and the multiply, you just have to prove it. Multiply equals to 1. So this is basic general convention that you have to remember. So now there must be some evaluation that evaluate this minus 1 plus under root minus 3 power 8 plus this one. So how to evaluate? So this must be minus 1, that it must be minus 1 plus under root 3 power 8. This is 8. This is plus under root 3 upon 8. So this is the general equation. So first you have to divide and multiply with 2. So when we divide and multiply with 2, this must be equation equals to this one. Divide by 2, 8 plus 2, that must be, this value is negative, this is also negative inside the cube. So minus 3 upon 2 power 8. So this value equals to, as we know with plus, it equals to omega power 8, that this whole value equals to this one, and then with minus we know that this value equals to omega square. So this value must be 2 times 8 is 256 omega 8 plus 256 omega 16. So after this there must be 256 common, and there must be omega 8 plus omega 16. So just for little, yes, now this equals to the last equation, 256 into omega 8 plus omega 16. Now this omega, now this omega 16, omega 8 must be subdivided into omega 6. Omega 6 is basically omega cube into the power square, so it must be omega 6 multiplied by omega 2. Then there is sum, then there must be 16. Why I am splitting in omega? But because omega cube equals to 1, so omega cube into 5 into omega, so this must be 256, and this value is nothing but it equals to 1 square omega square plus this value is 1, and this must be omega. So this must be equals to 256 omega square plus omega. So 256. So what is the value of omega square plus omega? As we know that the value is value of 1 plus omega square. This is summing equals to 0. So omega plus omega square equals to minus 1. So putting here the value equals to minus 1. So minus 1 multiplied by 256 equals to minus 256. So this is the general example. So to how to solve the values relating with the omega and omega square. These are questions related to the cube root of unity. So this is the end of the lectures today. So we'll meet in the next class.